Hi, everyone. Hello. Thanks for coming. We're here to talk about orchestrating Google Compute Engine through Google App Engine. My name is Alon Levy. I'm a tech lead and manager for Google App Engine. And this is Adam Eijdenberg, product manager for Google Compute Engine. And today we're going to talk about orchestrating Compute Engine through App Engine, but more generally how to use Compute Engine and App Engine together. And so let's get started. So first off, some of you are asking yourselves, why should I care? Why is it useful to use these two systems together? So quick show of hands, how many of you have used App Engine already? OK, so wow, a lot of people. That's awesome. So you guys are already aware, App Engine's been around for a while. It provides a very specialized, optimized container for running applications where we take care of all of the details of scaling and managing your resources, and you focus on your application code. But over the past couple of years, we've talked to a lot of our customers, and they've told us that sometimes they run into things they just can't do on App Engine. Maybe they want to run a language that's not supported, or they want to run a piece of third-party code that they've either written or picked up from open source, and there's no way to do that in App Engine today. So that's one reason why you might want to use them together. How many of you run an infrastructure as a service solution or VMs, something like that? All right, so less people, but still a good show. So on the other hand, for those of you who are comfortable working with your own infrastructure solutions, there are some things as part of your infrastructure solution you may want to break out and run in a platform so that you don't have to manage or maintain. And so that's another really good reason. And so we're going to try to touch on those as well as a variety of other reasons. So App Engine and Compute Engine. Let's talk about what they have in common. So they're both computing containers, compute containers. You write your code, and you push them to our products, and then we manage the machines. So App Engine is platform, Compute Engine is infrastructure. There's sort of two different levels of abstractions that are best suited for different types of tasks. App Engine is very specialized, where Compute Engine is very flexible. And so to get the most value, you're going to want to use them together. We plan to show you when you might want to use both and show you some patterns of how to wire them together. But first, let's talk about what they have in common. So obviously, you guys are here at Google I/O. They're both offered by Google in the same way they're used to using many of Google's other services. They run inside Google's data centers, and they give you the scalability and power that you're used to getting. They're offered as a service. You go to the website, you click of a button, you've got your resources, and you're ready to go. So Google's data centers. Google runs a state-of-the-art, efficient, secure network of data centers that is awesome. By running your apps there, you could take advantage of what we've built and iterate it on for our own purposes and our own products, such as Gmail, Calendar, et cetera. But I'm not going to get into all of the details. But if you're interested, you can check out that link and read about them for yourself. So Google App Engine, platform as a service. Easy to write, simple to scale, and trivial to maintain. App Engine gives you a specialized, optimized container for running certain workloads incredibly well, where you don't have to worry about anything except for the logic and the system that you have to build. It's fully managed, there are no machines to administer, and it's auto-scalable, meaning it'll turn on more resources as you need them, and it'll turn them down when you don't. Fully integrated also, so it means you've got a variety of services and tools that are available and just there for you to use. You make an API call, you get access to things like the data store, task queue, memcache, search, a variety of other things. So when is App Engine optimal? What kind of workloads is it best for? In general, it's when you don't want to worry about the infrastructure. When you just want to focus on the code. So things like web UIs and API endpoints are good examples of this. You want to make sure that your API endpoint or your web UI is always up and running. Even if there are issues in other parts, even if you're getting a ton of load, maybe you haven't provisioned enough resources, you got really popular, you want to present your users with something useful, something custom, something that you can present to them. Even if the rest of the system is having issues, you just don't want to worry about that, you want it to just work. Other types of things are workflows. When it's really just about the logic. You want to string a bunch of things together, you want to make sure they work in tandem, and you want to make sure that they get retried and the systems are up. App Engine is a great way to do that. If you have a managed backend, you want a stateful service, and you don't want to worry about, you don't need low-level access to the machine, but you want to make sure that it stays up. App Engine provides backends, and you can do that there. But as I said before, App Engine doesn't serve everybody's needs, so that's why we have Compute Engine. Infrastructure as a service. It's high performance, easy scalability, and it's a great value. It gives you the ability to reach down and actually get to the raw part of the VM and run any code you want. So you're able to get the high performance that you need to, or run off-the-shelf components, things like that. And so when is it optimal? So in general, it's when you need low-level access or fine-grained control. As you saw in the keynote yesterday, it's great for large batch workloads when you want to turn up a bunch of highly optimized processes to just churn through a lot of work, or when you want to fine-tune and run native code, or you want to run languages that aren't supported otherwise on App Engine. Also, if you're used to using your favorite open source stack and you just want to do that, you can do that with Compute Engine. So when do you use them together? Sort of a summary. When you want to get unstuck from platform, to extend the power of your App Engine app with some high-performance system that you've built that you want to run on Linux VMs, or to simplify your infrastructure as a service systems, to sort of break out the components that you don't want to manage, you just want them to run all the time, and then you can focus on the logic of that system and then writing the code that goes into your VM. And so now I'm going to hand it over to Adam to walk through the demo that we built and show you guys how we put these two systems together.
Thank you, Alon, for the introduction. So yesterday, we were absolutely thrilled to be able to finally announce Compute Engine to you guys so that you can get out there and start signing up for our limited preview program and start using it. Today, I'm going to walk through an example application that we're going to build. We're going to try and exemplify the two types of workflow that we think makes complete sense to integrate Compute Engine with App Engine. We're going to get unstuck from platform as a service, where we have where we need to use a native process to do some work, and we're going to use App Engine to orchestrate and manage the service that we have running there as well. So the premise for the sample app that we're going to build, we're going to build some of the components that you might need for, say, a website that does video sharing. And the three pieces of that, obviously there are very many pieces that go into a site like that, but the three pieces we're going to look at today are being able to upload files directly from your browser into our cloud storage offering. We're going to look at how you would then process those files, maybe transcode them to another format using a native application that we can't run on App Engine. And then we're going to look at how we can manage the virtual machines that are running and use App Engine to monitor those, create new ones as needed, and remove old ones that are no longer necessary. So the basic architecture for the application that we're going to build is as follows. We're going to have App Engine serve the front end to our users, and that is going to be the user interface that they use that will automatically scale to be able to handle all of the user-facing traffic. When videos are uploaded through that, we're going to create entries in a task queue, and that's a pull task queue that we can then use for our worker machines to consume tasks from that queue and then proceed to do the workload that they need to process on there. We think one of the key parts of our initial offering of Compute Engine is our workload processing to be able to use the performance and the scale that we have there. Once we have that data, we're going to write that back to cloud storage and use cloud storage, our internet sort of object store, to serve that data back to users. So I'll switch to Alon for the first demo, just to show the first part of this application, and then we'll go through and talk about some of the back end, how we set that up. So Alon, would you like to maybe drag and drop a file from maybe those two small files into our application there?
I would love to. Let's try this again. Drag and drop, very difficult.
Okay, while we're waiting for those to upload, we always have that little moment where we have a gap. And one announcement we forgot yesterday was actually my mother's birthday. And I was a really bad son. I'm a long way away, and we got caught up with the Compute Engine announcement, so I forgot that. So we've uploaded those files. Those have now come up in the application here. The first one has uploaded. It is not only has it uploaded, we track the progress of that. It's put an entry in the task queue. Compute Engine has processed that and put it back on there and sent that back to the browser through the channel API. So let's maybe go through in a little bit detail what happened on the back end. You switch back?
Yep.
Okay, so here's the basic workflow that we've used here. We have the browser as the person on the left, and they want to upload their file. In this particular case, we're not uploading directly into App Engine. We are doing the post directly to cloud storage. So we're bypassing the entire App Engine framework there. What we are using App Engine for is that we're doing a request to App Engine to create an endpoint where I can upload that file to. And we're doing that using a self-signed policy that we'll talk about in detail in a minute, which is a feature of cloud storage to allow temporary access to a particular location to upload a file. Once that's uploaded, once we have that endpoint, we then create a form object. We submit to that with the data that we have. And then we can report progress in the web browser to show you what percentage of the file was uploaded and what speed it's being uploaded at. And we're using some of the new HTML5 functionality here, such as cross-origin resource sharing, cores, and some of the permissions that are associated with that. So going through that in some detail, I'm going to show some code today. What we have here is some of the JavaScript that we have running in the browser. So we have a number of parts here. We have this start upload command. And here we do an AJAX call back to our App Engine app to get this upload endpoint. We then create a form data object, and we take all of the parameters that the App Engine call returned to us, and we pipe that into our form data object. We then append the file to that as well. We create the XML HTTP request to do the upload. We add listeners to that to track the progress and to track when it's complete. And then we start sending that. We're also using the data transfer object and the files on that in HTML5 to make that drag and drop area where we can put that file in there. On the back end, I'm showing now some Python code that is on our App Engine app. So this is where we're creating the endpoint for uploading the file. And this is kind of the first part before we get into Compute Engine, just getting the files into cloud storage, which is a good location for us to process these. So here we're creating a policy. We set an expiry date that says for the next 1 hour period of time, we want to allow people to upload files to this specific URL. And this URL contains a random UUID that we generate on the fly. That creates a policy document that we then sign using the App Engine app identity module that uses the service account, and I'll talk more about service accounts shortly, but it uses the service account associated with the App Engine account to sign this policy so that cloud storage, which knows that the service account has permission to write to that location, will allow the post to succeed on the next step. Then we return that data as well to the full endpoint, as well as the other parameters that we need for the front end, for the JavaScript to submit that. So once the file has finished uploading, we then create a task queue entry. We do that from the browser sends a message back to the App Engine app to say it's complete. We then create an entry in the task queue. Now we move to the, here's the, just to give an idea of what kind of things we're putting in that task queue. In the task queue, I'm just showing the payload data here. It's probably very hard to read at the back. But we have a UUID, basically the path in cloud storage where the file is located. And then some identification so that when the task is complete, the worker will call back to App Engine to tell it that it's done with some payload there to let us know that it's finished. So it's a very small payload. This moves to the second part. We've uploaded the files onto our system now. And now we're looking at what can we do once we're on the virtual machine. Let's set the virtual machines up to process these files as they come through. So we're using the task queue REST API, which is a way of being able to allow an external application outside of App Engine to be able to access the task queue within App Engine. We use the service accounts that are on the Compute Engine instances to automatically authenticate back to task queue. And then we have a basic loop that runs in a worker thread on each machine that does one very simple thing. It polls the task queue for new jobs. When it finds one, it requests a lease on that job, which means that no one else will get that job, but that lease expires after a set period of time, say 30 seconds. It then spins off a thread to do the actual work to process that job, and it monitors it. And if we get close to 30 seconds but the job's not finished, we then update the task. We extend our lease so that it doesn't expire and that we keep that job until we're finished. If for some reason our machine, if we had to terminate our machine for some reason, another machine would automatically pick up that task as soon as it expires. When we're complete, we delete that task, and then we do a callback to our App Engine app to let us know that the task is complete. let's go through some of the code on there. We have a task processing loop. We will make the slides available afterwards. I see a lot of people taking pictures. We will make these available. So the first part here, we have our loop. We're requesting a lease on the objects on the task queue. Once we find an object that's come through, we then decode the payload that has come with that, and we spawn a thread to do the actual workload. We then have a loop that attempts to join that thread and times out after a certain period of time. If it times out and the thread is still alive, we then extend our lease on that task queue so that no one else gets that job until we're finished. Once we're complete, we delete the item from the task queue, and we're done. So that's kind of the main container thread that I think will be quite generic for a lot of workload processing within a virtual machine. The actual specifics of what our particular workload does in this case, after we spawn that thread, is we copy the source file from cloud storage. We copy that locally. We then run a video transcoding library. In this case, we're using FFmpeg to convert that to a different format and a different resolution. And then when we're finished, we copy that file back again. So it's really quite a simple actual workload processing at the end of it. We have a little bit of code here. This is probably the least interesting part of the talk, but here is what we're actually doing on the server after we spawn that thread off. We're just doing a very basic sub-process call to call gsutil to copy the file across. We could also do that programmatically, but this is fairly straightforward. We then spin off the FFmpeg library with a whole slew of options to re-encode that. We run gsutil to send it back again. And then finally, we change the access control on that file to make it publicly readable to serve through our website. And then we do some cleanup at the end, and we do the callback to the App Engine app just using a standard URL open command in Python. So let's talk a little bit about the virtual machines. So we've written our script now, and now we want to get it on a virtual machine so we can test it and start playing with it and getting it to run. So from my workstation, I can run the gcutil add instance command. And this is where I can spin up a new virtual machine from my command line. I give it the zone where I want it to create. I give it the machine type. In this case, I'm picking 8 cores. And here I'm giving it some service account scopes. And what that means is that we're automatically going to provision a service account on that machine that will have permission to acquire tokens to access task queue information and have full control over my cloud storage area. After that's created, and it doesn't take very long to create, I'm using gcutil to SSH to that machine. And so gcutil wraps the SSH command. It makes it very, very simple to secure shell into a machine that you have created and not have to worry about putting usernames and passwords in. We use all the public key system for that. So once we're on that machine, which here is a standard Ubuntu 12 image, we can then have full root access over that machine. So I can install any package I like. So I just run sudo. I'm on the sudo list automatically. I can install anything I like. I can then copy information from my cloud storage area directly onto the machine using gsutil. And the neat thing about this is because we created the machine with these service accounts, I don't have to run the gsutil configure auth command and do the auth dance and go to my browser and paste things in. We've already done that on the back end. gsutil is designed to use that service account. So long as the bucket you're copying from allows permission to the service account named for this project, virtual machines, that will run without any further work on your behalf. And then I can set the job up, run it, debug it, and play with it as much as I like. So I just wanted to just take a moment out and just talk a little bit about authentication and authorization. This is something that I found personally when I was integrating 3 to 4 of our different products together here. A little bit daunting at first to figure out the difference between the various types. Essentially, we have what we call a service account, which is basically a pretend user that represents an application that you might want to allow to access other resources from another project or access another application. So it doesn't represent the person using the software. It represents, say, I want this set of virtual machines to be able to access a task queue, or I want this web application to be able to write files to cloud storage. And we have 3 really two, but it kind of looks like three different types of service account within the Google ecosystem. We have service accounts that you can create through the developer or the administration console API, which is where you can create OAuth tokens for installed applications or web applications or service accounts. And when you create one here, we allocate a big long email address, that's the name of the service account, and then we give you a P12 private key to download. You have to download that file, and then you can use that anywhere, whether it's within Google products, whether it's on your desktop, whether it's in a different cloud infrastructure. You can use that to sign requests to get an OAuth token, but you have to manage distributing that key yourself. You have to make sure it's secure. You have to make sure it doesn't get lost anywhere, and you have to do a lot of the hard work there. But it is portable. You can run it anywhere. The second types of service accounts we have are what we call provisioned service accounts, which is where within both of our code execution units, both App Engine and within Compute Engine, we have the ability to take care of creating automatically a service account for you. So in App Engine, we have the app identity module. We have .get access token. And in Compute Engine, we have a metadata server, which I'll go through in a little bit more detail in a minute. But these are both ways that we will automatically create access tokens for you. Or we can sign blobs for you, so that you don't have to worry about distributing those keys yourself. The downside is it'll only work within that container, but the positive side is much easier to deal with. So I just wanted to take that little note out to talk about those two different types. They're interchangeable. Both of them will give you an email address that you can then add to access control lists. In our example here, we have a queue.yaml file, which represents the pull queue where we're putting the video jobs into. And we had to add permission to the Compute Engine service account to be able to read from that queue. We have access control list within cloud storage. So I gave the App Engine account permission to upload files into cloud storage, and that's why it was able to sign that blob for the self-sign policy earlier. And we also have the ability to add that within the Teams page in the administration console, or the development console. So that in this case, the App Engine service account, I've added that as a team member to my Compute Engine project. So the App Engine app is able to create virtual machines and tear them down and take care of that management for me. So I hope that helps give a little bit of clarity on the different types of service accounts that we have there. So let's talk a little bit more detail about how we authenticate from within a Compute Engine instance. So within App Engine, we have the get access token method that we saw before. But within Compute Engine, we have a metadata server. And on this metadata server, this is a server that is available only to your virtual machine. Every virtual machine can access a different one. And it lets you see various bits of information about the virtual machine that it's within. And one of those has a particular path you can go to that will acquire an access token for you based on the service accounts that we used when we created that virtual machine. And you can call that programmatically from within any application on there. You can call it with curl to test it to make sure it comes out. It will take care of refreshing that token for you. If you've used service accounts before, they'll time out after a certain period of time. This will take care of that for you. You can call this every time you need a token, just call it, and it'll return a token that will work. So in our particular application here, we're calling this from within a Python, within our task queue in the Python area. And here I'm calling it. I'm telling it I need the scope for the task queue, which matches up against the permission I gave the virtual machine when I created it. And I'm putting that inside of an access token credentials object. And the reason I'm doing that is because every time I am executing a call against that task queue API using our Python API client, I'm passing then HTTP object based on that access credentials that we returned. So this is kind of a gap I kind of omitted from the previous slide there. So let's talk a little bit about what happens after we finish processing. So let's remember where we are. We've uploaded files. We've had an application run on a virtual machine, find those files, run FFmpeg over them, copy them back to cloud storage, and now we call the callback into the App Engine app, which has a payload, which was passed to us as part of the queue, and that tells us what job is now complete. And the App Engine app is now pushing that via the channel API directly back to the browser, so it'll pop straight up in front of the user there. We then serve that video directly from cloud storage. So we do the request straight back to cloud storage to get that data. So we've talked about the first two parts that I wanted to talk about, which were uploading files through cloud storage. We've talked about how to get unstuck from our platform as a service and be able to run native code. And the third part that I'd like to talk about now, which I think is really interesting, is how we can use App Engine to actually control the virtual machines that are created and automatically scale and make sure we have enough virtual machines to handle the workload that I'm being passed. App Engine already does a great job of this for the user-facing requests, but we need to do something on the back end to make sure the virtual machines come up in the same fashion. So I'm going to start with the diagram, and then we'll jump to a demo. We're doing essentially two things to facilitate this. We have each virtual machine has a heartbeat on that is calling back to App Engine that gives it information about the CPU utilization on that machine, information about what throughput it is achieving when it is converting videos, and some other statistical information. Separately, we have a cron job within our App Engine app that periodically calculates how many virtual machines we think we need to process the amount of work that we currently have outstanding. We used a very simplistic, very simplistic algorithm for this demonstration in a minute, where we look at the throughput that we're achieving, we look at the total number of outstanding work in terms of gigabytes or megabytes of video we have in the queue, and then we divide that out to reach a target of we want to be able to process all of our videos, if everything was spun up, in about 30 seconds. I think there's probably far more sophisticated queue control theory lessons we could go into about different ways of doing the scaling. But this is just a simple example we're going to use today. So let's switch back to the demonstration.
All right. Oops. There we go. All right.
Okay. Alon, do you want to go to the advanced options?
Yes, let's go advanced.
Okay. And I'll explain what the graph is in a minute, but just let's drag and drop the, before you drag and drop that, maybe change that number of uploads number to maybe 1,000.
1,000?
1,000.
Okay.
And now let's drag and drop that demo video there. Now the first video we uploaded was pretty small, it was only 1 megabyte. This one's not huge, it's 9 megabytes and it runs for about 3 minutes. But I wanted to pick one that was slightly bigger, but not big enough to challenge the internet connection that we might have here. And what we have on the graph here on the right, we have 3 lines. The red line that we see tracking up is the amount in gigabytes of outstanding videos that we have to process. And the axis for that is on the right of the screen, and we can see that's about 8 gigabytes of video we've uploaded. We cheated a little bit. We uploaded it once, but when I passed that parameter of 1,000 there, on the back end, the App Engine created 1,000 entries in that task queue to each re-encode that same video, but write it back to a different location every time. So the blue line is a little bit difficult to see at the bottom there, but the blue line is showing CPU utilization for 100 virtual machines. So on the left, we can see how many virtual machines we have running. The yellow line represents how many we have running right now or have requested to run. So when we started this demonstration, we had exactly 2 virtual machines running. And when we created all these other entries in the task queue, we realized we needed a lot more virtual machines to be able to process this data in a quick fashion. So we decided that we needed 100 virtual machines. You can see they quickly jumped up to 100. They haven't started instantly, but that's basically the point in time where our app has decided that it needs those extra virtual machines. So what we can see coming up now, the blue line is representing the cumulative CPU utilization across all of those virtual machines. So what that means is that when that blue line hits the yellow line, we are 100% spun up and we are 100% processing videos. We're doing pretty well.
Yeah, they're starting to come in.
Yeah, so what we'll see here.
The demo is working.
Sorry?
The demo is working.
Demo is working, which is good. What we can see on the left here is we can see the videos coming back. What we did when we went to the advanced mode, we chose not to show the videos as they returned, because then I have my web browser trying to download 1,000 relatively sized videos in a short order of time. But later we can click on one of those links just to verify it's not an elaborate hoax. So those are coming back. I kind of get excited when I see that blue line go up and I start seeing that red line absolutely shoot down there. So that goes pretty quickly. What I think is really interesting actually is the consistency we see from Compute Engine. If we get patient and watch this for a few minutes, we'll typically see it sort of go down and then it will flatten and then go down again. All the videos are the same size, they all start processing at the same time, and they all finish pretty much at the same time. We have a little bit of delay in there. We can see the CPU utilization is not quite 100% anymore. That's expected, and the reason for that is we have 5 threads on each of these virtual machines. They're all 8-core machines, and I've set it to begin 5 worker threads on each. So 5 times 100 is 500 worker threads, and as we sort of run out of content to process, we only uploaded 1,000 videos. We do sort of run out of jobs pretty quickly. And we can see we're finishing off there quite nicely now. So Alon, maybe while we're waiting for that to finish, can you switch to the second tab out there, and let's maybe increase the number of virtual machines that we can have processed to, say, 400.
All right.
We'll hit update, and then maybe go back to that tab. You can see that's just about finished. Oh, okay, go back to the advanced options. Let's make the number of uploads, and we can see we've rescaled that now, so the axis on the left is now showing we have the 100 virtual machines on scale up to 400. So let's maybe upload 4,000 of those files.
Yep.
And that'll take a few minutes to start up. So we'll switch back to it in about 5 minutes.
Yep.
And I'll just talk through a little bit more of the code, and we'll show you how that's coming along. Okay. So just go through a little bit of the detail on what's happening on each of those virtual machines to support the scaling part of that. We have a very simple heartbeat script I have running on each box, and that box is simply running mp-stat every second for 1 second, and is then reporting that back to App Engine through a callback to an endpoint that we pass as a parameter when we create the virtual machine. And that's the callback just spinning up there. We have a very simplistic code here for the scaling of the virtual machine. We have in App Engine, we have an entity for each of the VM instances that is running. We then sum up all the throughput we're seeing for each one. We then add up all of the videos that we have outstanding. We have a status on that for 0, means it hasn't finished yet. We then do some pretty rough and ready math on that to figure out how many virtual machines we actually need. And I had that settings page earlier in the administration console, in the App Engine app, where I could specify a min and a max number of virtual machines. That's just a standard App Engine page I put in there to play around with those settings. So we have a floor of the min and a ceiling of the max. I can control how many workers I want per virtual machine. And then we do some pretty simple math here. We say, if I don't have enough virtual machines, go and create some more, and if I've got too many, terminate the old ones. And I just thought I'd take you through just a little bit of information about how to create a virtual machine. We did it via the command line before, but I like to do it here through our REST API and show some of the fields that go through there. So the first is I'm picking a fairly unimaginative name for each virtual machine just based on UUID. I'm using that. There's 2 ways I can start a virtual machine. I can either use a stock standard image and then run apt-get and install all of the packages I need on there. And I did that for a long time. And then the other way to do it is you can do that once, and then you can create an image, upload that to cloud storage, create that within your Compute Engine project, and then refer to that image when you start subsequent virtual machines. So that way I don't have to reinstall the software and pound everyone's mirrors when I'm trying to pull down all those packages every time. So here on the right, I'm pulling up a particular image that I've created earlier. I select the machine type and the zone where I want to put this in. I have all these running over in this, I think on the East Coast today, or the central zone when I created this slide. I'm picking the 8-core machine type so that I have nice beefy virtual machines for my processing, so it runs nice and quick for us. I specify some information about the type of network interface I want on that machine, and here I just want a really standard default configuration, so I'm just using a basic setup. Here is where I create the service account, and I tell it what service accounts the metadata server should allowing to acquire a token for. So here, both task queue access and full control over my cloud storage. And then finally, I'm able to add a startup script to that machine. So while I created the image that has the software installed on there, I still left a simple startup script here so that I could then pass some information to it as to, here's what to do when you start up. I want you to start 5 task queue readers and maybe 1 CPU heartbeat monitor that we had written there. And we pass as parameters to that information, such as the App Engine app that's running it, so that we can get those callbacks through there. We're using the standard Python client API library that we have, and like literally, that's all it is to creating a virtual machine. So that's how are we going there, Alon? Will we switch back to
We're getting through, yeah. We can switch back.
Let's switch back and see how we're going with our virtual machines. Live demos, always fun.
Coming along.
Okay, so we have actually created 400 virtual machines, which is pretty cool. What is actually quite interesting too is we can see on the top left there, we can see that yellow line is dipped just a little bit, and what that is it's figured out that, hey, you know what, we've actually got a few too many virtual machines running. We have 2 that have been running for a couple of hours already from before this demonstration. They're no longer needed, and so I may as well terminate them now so we don't get billed for those. I keep the other ones running. There's no point terminating something in less than close to 1 hour because that's the most efficient way to optimize for your resource usage. So let's finish off there.
All right, we're all done.
So maybe Alon, let's upload 10,000 videos.
All right.
Maybe let's show the dash this time as well.
10,000, and we'll turn out this little dashboard that shows us the throughput we're getting in, what is it? It's hours of video per minute?
Yep. What we're showing down there is how many hours of video we're actually processing per minute when we upload this. So let's drop that on, and that will reset the counter.
So remember, these virtual machines are all up and ready. So there's no initialization required now. It's just going to start processing.
Okay, so the timer reset when that file was uploaded. We now have 10,000 jobs being created in our task queue on the server there. We'll see that red line scale up to about 80 gigabytes. So we have about 80 gigabytes of video being processed. We'll see that that dashboard will say 0 for a little while. We have to wait for the first video to finish processing before we update that dashboard. It's when we get the signal back to our application that finishes. We can see the CPU utilization. It's jumped up to pretty much 100%, which is good. And we'll see how quickly those videos process. Bit of a dip in the red graph. I suspect that's a bug in the order of how we're displaying those numbers there. We'll see those begin to come in. The ones that picked those things up from the task queue first come in pretty quickly. The others should start coming in pretty consistently. We're about the 1 minute mark here. We have that line moving pretty quickly up here. We have about 2,000 worker threads. We have 5 times 400, 2,000 worker threads here, and they're kind of all finishing at once. So I think the channel API is doing a really good job here. So what are we at, 67, 68? And I think we'll probably hit steady state at around 70 until maybe that second batch of videos start processing in, which I think will probably trickle in pretty shortly. We can see that number's dipping down. That's just because it's an average from the start to the finish there. Let's just maybe wait for that second batch to start coming through. Then we'll flick onto the next slide. We've probably seen enough video processing at that point. Again, we can see that consistency in the performance of Compute Engine there. Even though we have 400 virtual machines here, we can see it processing pretty much the same rate, and we'll see a step function as that red line decreases as we finish those jobs there. Just to note, on the App Engine side, I'm using the task queue for this. Because I was spinning up a relatively large number of workers consuming that task queue, one of the things I did there is I sharded that into 10 separate task queues. So every time we're creating a job to put on the queue, which I'm actually creating in batches of 50, I'm randomly picking one of those task queues to add that 50 jobs to. And on the other end, on the virtual machines, each one of those, when it polls a task queue for a new job, it randomly switches between those 10 task queues that we have running there. And we can see that that's running pretty nice and quick. And we've got 192 hours of video. That's about a week's worth.
73 hours every minute, yeah. So
yeah,
pretty good, 2 minutes.
So, oops. So let's flick back to the back to the slides. So yeah, we wanted to show you two things today, and I think the two really interesting ways to use Compute Engine and App Engine together are, again, within App Engine, you're building an app, does a great job of the front end, does a great job of a lot of parts, but sometimes I just need to run some native code. And I think this is a really great way of being able to interact with Compute Engine to take care of those large workload processing. And I think the second part that's really interesting is, let's say I have a large workload that does a lot of work. Something needs to monitor those, something needs to keep track of those, something needs to curate that and look after that. And I could create more virtual machines to look after my other virtual machines. Then kind of someone needs to look after those virtual machines, and maybe we'll get another one to look after those. And it seems to me that App Engine, we already have a lot of people at Google looking after App Engine, making sure that's up and running for you. And I think it's a really neat way of being able to have something that I know is always up and running, and something I can rely on to manage all of those virtual machines that I have running in my environment. So Compute Engine, we are in limited preview. Please visit our website and sign up. We're taking requests now for a period of time. I have a bunch of reference URLs. I'm not going to go through them in detail now, but just to show all of the various bits of documentation that were relevant to the parts of the demonstration today.
Cool.
I'm sorry, this will be up on YouTube within the next couple of days, I think. So
we'll put the slides up online
we'll put the
too,
slides
so you
up,
can
absolutely.
copy paste.
Yeah. So any questions?
Thank you very much.
Yeah.
And one more thing I should add. I don't know how many of you guys stopped by the cloud platform Sandbox area where we had those delicious chocolates for the past 2 days. We've only got a few boxes left, so we're going to hand them out to people who ask questions. So take it away.
Right. You mentioned about using provisioning APIs to access the compute itself as a resource, right? Obviously, it helps a lot in elastic computing, but one of the common use cases from a functionality standpoint is to use the existing resources, the 4 resources: Memcache, Bigtable, Cloud SQL, and you showed already cloud storage. How do you use that as a provisioning? How do you access those resources using the provisioning API from cloud compute? Am I making sense here?
Yeah.
Yeah, absolutely. I mean, some of those we can access today. So Task Queue has an API that we hit today. Cloud Storage, of course, has an API. We're looking at ways of making it even a cleaner integration with some of the other App Engine components there that are really, really valuable to people. Exactly like you said, like Memcache, like Data Store.
So yeah, so it's not all quite there yet, but we're working on it, and hopefully
okay.
we'll have more to announce soon.
So currently, the one that you're using is going to be 2 separate requests, one on App Engine and the other one on course. So it's like JSONP, which makes a separate independent request to Compute Cloud.
So talking between App Engine and Compute Cloud, we're making HTTP requests between the two.
2 different requests.
Well, yeah. I mean, when Compute talks to App Engine, that's a request and then the response. And then if you want to talk to Task Queue or Cloud Storage, you can talk directly to that service. But for things like Data Store and Memcache and the like, we're still working on those.
Okay.
Cool. And you can come up and grab a chocolate bar if you want. Or you can come by after.
Hi, hello. I was wondering if there is a way to manage the keys we create, to set an expiration, revoke, recreate the keys.
For the
service accounts.
For the service accounts?
Mm-hmm. Yeah.
If you're using the provisioned service accounts, we take care of a lot of that complexity. Are you talking about ones that you create in the administration console that you download?
Mm-hmm.
I should come and talk to us later. I'll check with the team on that. I think there's a way that you can revoke those from within the administration area. I don't know if they can be set to automatically expire or not.
Okay. One last question. Any plans to open source the sample you showed us?
Yeah, absolutely. We probably need to get back to the office, let the dust settle a bit, and clean some of the code up for you. I tried to put as many of the crucial parts of the code into the presentation that will get out sooner than probably the rest of it.
It should work the same if I use Python or Java, right?
Yeah. I mean, all those APIs are
yeah,
work
absolutely.
well
There's no need to use Python there at all. I like it, but there's absolutely no reason that you need to use
thank you.
Cool.
How does Compute Engine differentiate from AWS? Is it usability? Is it just the brand?
Performance. We see very strong consistency of performance. We see value in terms of how much compute you get for your dollar, and consistency and scale.
Does that consistency go down to disk level, like storage level?
So we have, yes, essentially. So if you have, it's probably best to talk to, we had a number of our partners and trusted testers get up yesterday, and you can always listen to us. It's usually good to listen to the users of it. And they had very favorable things to say there. I think if you have a 4-core or an 8-core machine, then you're guaranteed to get your own spindle. 1 or 2 spindles, Joe? 1 spindle. I have our tech lead in the front row here, and he's nodding at me a lot, so that's always a good sign.
It's a good sign.
And our consistent disk product has less than 3% variance on random 4K rewrites.
Okay, I'll just repeat that from our tech lead. Our persistent disk product has less than 3% variance on random 4 kilobyte read writes.
Yeah.
Good job. All right.
Hi, I was just curious if you had any idea of how much work difference it would be if you created that whole application just in Compute Engine, and would you do some kind of comparison of that? Just what's the value added of App Engine?
Yeah, I think you could go either way, right? So I guess it depends what environment you're most used to. If you like App Engine, if you want to build it on the platform as a service, I think that's a great offering. I found the task queue a really natural way of being able to access those Compute Engine resources. All those heartbeats reporting back from 400 VMs very quickly, that actually needed to spin up a number of App Engine instances for that, which kind of surprised me, but I was really glad it did that automatically for me. I didn't even have to worry about that.
Yeah.
You could build that front end directly on a LAMP stack if you wanted. You go either way.
The other nice thing is that because we did the development through App Engine, and App Engine was sort of controlling and provisioning the VMs, as the development was happening, all we were doing was deploying an App Engine app and using the App Engine tools and sort of using that and using all of the monitoring and logs and things that come along with that. And so, you still get the fast iterative cycle that you're used to with App Engine, and then it takes, and then the management of the VMs is done from there. So,
Just any gauge for how much more efficient you were in genning up the app because of that?
Well, we didn't try it both ways, so it's hard to compare. But you're welcome to give it a try and let us know. Thanks.
I was impressed by the different tiers of storage that you put into Compute Engine, the persistent storage, the ephemeral storage. Are there plans to making the persistent storage mountable through App Engine?
That's something we can think about. We don't have any concrete plans right now.
Thanks.
Hi. With the Google VMs that you spin up, is that the standard Ubuntu Linux? Is there anything special about it? Or are there any limitations that you guys impose, that stuff that you can't do as opposed to kind of the plain version?
Yeah, they're pretty standard. We do have our own kernel on that we've hardened and optimized for the environment.
Okay, cool, thank you.
So you explained the use cases of App Engine and compute. There is this intermediate thing which is called backend. So what is the plan for it?
Yeah, so backends are a way to sort of run a stateful, addressable service on App Engine. You sort of get the advantages of having App Engine take care of it and being able to scale, if you use dynamic backends. But it's sort of different than compute. You still can't run native code. It's still the App Engine container, but it's sort of halfway in between. So you can use it for things where you don't really need access to the entire machine, but you want some bit of stateful services. So, I think there's a place for it in between somewhere.
Okay.
Yeah.
I'm curious if your examples you showed us today, the whole transformation, storage, and all this, can you make a guess if these examples would be a real-world application, how much money you have burned for this?
So that's a good question. So the App Engine app I have set up, it has billing turned on because I like to be able to see what happens there. The App Engine app is really very, very low, even for the burst I've been putting on there. On the Compute Engine side, the cost of those virtual machines that are only the 8-core, $1.16 an hour. So that times 400 for 1 hour of those running.
This is more of a legal question than a technical question. Do you know what's the licensing thing? Could we run licensed software on these?
Yeah, I think so. I mean, it's
So if like we were to run, you know, VMware or whatever it was that required a license, there's no issues with that.
Joe, I mean, do you answer this?
There is some software that says it can't be run in virtualized environment, so it's actually up to the provider for the license. So you actually have to read their license.
Got it.
We don't have any restrictions that we can get into, but they, the actual provider of the software, may have restrictions.
Right.
So you can always go back.
Okay, I'll just repeat that answer. So the answer was that you need to check with the provider of the software. It's their license. Some providers won't have restrictions, some will.
From Compute Engine's perspective, you could run it, but it's up to you to figure out if you're allowed to.
Are there any plans to have specialized CPUs like AMD Radeon GPUs available in a compute kind of format?
I'm sorry, what type of GPUs?
Like an AMD Radeon GPU.
Graphic GPUs. I think that's something that we can think about. I don't have anything concrete to announce today on that. Cool. Okay, well, thank you everyone for your time this morning.